Good evening, Verona. Thank you very much for being here, and I'd like to thank the organizers for giving me the opportunity to talk to you. Today, I want to talk to you about performance. But before I do that, I would like to tell you a story. I was working in the office the other day, and a colleague of mine came up to me and said, "What are you working on?" And I replied, "I'm working on some performance improvements." And he replied, "Why are you doing that? Our servers are getting faster and faster, our phones and laptops as well. So isn't this a little bit of a waste of time? And is it really worth it?" And that question really struck me. I didn't know the answer right away, but I think I do now. If I manage to shave off just 10 milliseconds of a single page load time, then if enough users visit our website, we can turn this 10 milliseconds into minutes, hours, and even days. So yeah, I think it's worth it. My name is Krzysztof Slonka, and I love working on performance improvements. I work for a company called Allegro. You probably are not familiar with it, but it's the fifth largest online e-commerce website in Europe and the biggest one in Poland so far. So this is how the front page looks like. Its building blocks are components. For example, on the left, you can see a section component showing some categories from our shop. You can see a carousel in the middle, and on the right, there are some informations from my profile displayed in the user component. And all of that is created using a service called OpBox. It is responsible for rendering most of Allegro's pages. And shortly after I joined Allegro, I was transferred to the team behind OpBox to work on improving the performance of the service. OpBox is one of 900 microservices that we run in production at Allegro. But it's one of the bigger ones, so even a small improvements there will go a long way. So let's see how OpBox fits into the ecosystem. So a user can access Allegro both from the website and from a mobile device, and those two communicate with specialized services called OpBox Web and OpBox Mobile. And then they, on the other hand, talk to the centralized service called OpBox Core that has the access to the data that the user requests. And on top of that, we have OpBox Admin, which is an administrative interface so that the people working at our company can modify the website. Okay, so let's now go through a typical data flow to understand that a little bit more. So a user types in Allegro.pl, and that request is directed to OpBox Web. Then OpBox Web does some processing and routes that request to OpBox Core. Next, OpBox Core will return a JSON document describing everything that needs to be displayed on the page. And then OpBox Web will get that info and render the HTML and send that to the user. And OpBox Web is written in node.js, so we will focus on it in this presentation. All right, so to understand better how OpBox works, we need to start with its booting process. So it starts off as a single process, and then it will use Node cluster module to handle concurrency better. After that, it will spin off additional processes using our homegrown library called node worker nodes, and that will spin additional processes to handle CPU intensive tasks off of the main loop. Okay, and when all of that is done, OpBox Web will start receiving requests and giving responses. So you can see that there are two distinct parts. the top one is responsible for handling requests, and the bottom half is responsible for rendering stuff. Okay, so that is OpBox in a nutshell. We have our service. We want to make it faster, but how do we do that? Well, let's think about it for a second. There's no reason to optimize something that only occupies a couple of % of the CPU time. So, what we're gonna do now? We need to know what our process, what our application is doing most of the time. So, how do we discover that? We're going to use a technique called profiling. And profiling is basically measuring the frequency and sometimes the duration of the function calls. So there are two types of profilers. One of them is instrumenting profiler, and instrumenting profiler works by injecting code into the beginning and end of your function to measure the time it took to execute it. This method usually has drawbacks that it has a high performance impact, and that tends to skew the results. And also, we have sampling profilers, and they work a little bit like this. So, a profiler asks the VM, "What are you doing?" And the VM answers, "I'm executing function A, and here's my call stack." And doing that over a long enough period of time will give us enough information to know what's really happening in our process. Okay, so we know what technique we're going to use. How do we do this in Node? There are a couple of ways to do this. If you go into the documentation, the first one you'll discover is a command line switch called --prof. Another one is a tool called 0x that was mentioned here before. If you dig a little bit deeper into the docs, you will find it there. And another one is Linux perf. It's a system profiler, so it works only on Linux infrastructure. So you're not going to be able to run it on, for example, macOS or Windows. Okay, so we're going to evaluate those profilers or key characteristics. So what's their status? Are they actively maintained? Are they experimental? What's going on there? We're going to also think about what function types will that profiler show us. Is it only going to be JS functions, or are we going to see V8 functions or something else? Okay. We talked about OpBox, and it uses cluster module. So we also care about the profiler supporting cluster module. And what's really important when you run those kind of things in production is the ability to start and stop the profiler on demand. Because usually, even though the sampling profilers have low overhead, in some environments, it's not acceptable to run them for a long period of time. Sometimes they will gather a lot of data that has to be flashed to the disk. So it's really key to be able to start and stop them when we want. And we also care about setting the frequency of the sampling. So how often does the profiler ask the VM what it's doing? That can impact how much of a performance overhead there is, and can lower or higher that number. And lastly, I will try to judge if the profiler is really ready for the production environment. Okay, so let's start with prof. It's stable, it's in Node for a long time. It will show JS and V8 functions. It supports cluster module. You can't really start and stop it on demand. You have to start it with the start of the process. You can't really easily set the frequency. And because of those two things, I don't think it's really ready for production. 0x is also stable. It will show the same type of function, but unfortunately, it doesn't support cluster module. So for those same reasons, I think it's not really ready to be used in production environment. If you really can start and stop your application easily, maybe you can live with that, but I don't think it's a good idea. Okay, so Linux perf is stable, but with a star, because it will require some special modules on the node.js part, and it also requires you to have a sudo account and be able to actually install things on your production machine. So if you're not on the infrastructure team, that might be a little bit hard to do. It will show not only JS and VN function, but it will also show kernel stuff and native functions. And it supports all of the characteristic that I mentioned before. Because it's a system level profiler, it will profile everything. All right, so there's a couple of more there, but I'm not going to go through all of them. You can check out my GitHub. There's a write-up on what's available and what works with what. So we know there are a bunch of profilers. Which one are we going to use? Initially, I thought that perf is going to be the perfect match for us because it ticks all of the boxes, but as I said, it requires sudo, and there's some infrastructure stuff that you have to overcome. So we're gonna use prof, and we're going to use canary deployments to go and start off the profiled version of our app, and then stop it when we have enough data. Okay, so it's pretty easy to use --prof. We just add it to our command line options, and that will produce a isolate file that has lines like this in it. So basically it says what's being done at the moment and some addresses that correspond to particular functions that are being executed. Okay, and we take that file and we can run it through --prof process, and that will process the file and actually print out something that's a little bit more readable to the user. That will show something like this. We can see that there is a summary, and at the top we have the type of the function, the type of the summary we were looking at. This will be C++ code, JavaScript, or shard libraries, or GC. Then we have a column that says ticks, so how many times we recorded that event, the total percentage, the non-library percentage, and the name of the function. Okay, so that summary is quite good, but actually there are better visualizations. And we mentioned this tool before, 0x. We can use it, even though we're not using it for collecting data, we can use it to visualize the data. Okay, so 0x will produce something like this. This is a flame graph. Flame graph is a bottom-up chart. So we can see that we'll build it up from the bottom. We can see that the first function that is on the bottom is anonymous. Then the functions that are above it are the functions that were called by that function. So above it is a function called generate stats, and again above it is another anonymous function. And as we can see, the anonymous function is red, so we know that it occupies a lot of the, it's on the top of the stack a lot. And we can see that there are some smaller functions also in the flame graph. Okay, so the width of the bar corresponds to how often the function was on this stack. Okay, and also 0x will give us some handy tools, like we can see in the top right corner that there is a search bar and a hot call scale. Called functions are the functions that are not on the stack a lot. Hot functions are the ones that are, and those are usually a good place to start. So pay attention to them. Okay, so at the bottom you can see a couple of buttons, and there are two rows of them. One of them at the bottom will allow us to select more function types. So in your app, you have the code that you wrote, you have dependencies, you have some core code that is in Node, and you can tab on them to see all of them in the flame graph, or disable them to hide them. All right, so you also have buttons on the top row, and the most interesting one is tiers that will color the bar depending on which type of function it is. Okay, so we have our service that we want to optimize. We have the way to gather the data, and we have the way to visualize it so we can work on it. So let's go back to OpBox, and as I mentioned before, there are two distinct parts, the rendering one and the one that handles the requests. So let's go for the rendering first. Whoa, that's kind of a big flame graph. It is actually 150 megabytes of flame graph, and that kind of thing is really hard to render even. It took 20 seconds on Chrome to actually render it and for it to be usable. Okay, so we can see that there is a red function, so let's start there. If we zoom in, we can see that the function is called render. All right, so let's think about that. Can we optimize it? Well, the render function, as the name suggests, is responsible for rendering. And actually, the whole idea of OpBox Web is for rendering. So it's not really a mystery that it's visible on top of the stack a lot. I think we need to see more function types to really know if we can optimize something there. Okay, so I've turned up more function types, and if we zoom in now, we can see that above the render function, there is JSON parse. Okay, so let's think about if we can replace it or optimize it. So it takes around 15% of the time. If we can cut that down, it will be a significant boost. Okay, so I looked a little bit on the benchmarks on the internet, and I found out that JSON is not that fast compared to other binary types. And after carefully thinking about it and after considering it, actually, what I end up doing is writing the tests for a sample schema for our use case. So when I did that, the results were actually quite different. They were a lot closer. So that was one really important lesson. Always check the benchmark against your own use case. If somebody tests a library on some input that doesn't resemble your use case, the output will be really different. Okay, so this is one of the things. And the other is that when we thought about the additional cost that we will have to introduce into the infrastructure about describing the schema, then we thought that optimizing JSON parse is not really a good idea. Okay, so let's get back to the previous picture. I don't know about you guys, but I see a lot of yellow here. Yeah. If I filter it out, you can see there's a lot of yellow functions. And all of that is array.map. And as some of you may know, array.map has to handle a couple of edge cases when it does the mapping. So it will really need to check some things. And if we change that to a simple loop, we might go from actually being able to render 40 components per second to being able to render 45 and a bit. So that's pretty good improvement. It's 11.2%. So it's kind of a good start. Yeah, I think it's a really big win for us. So we optimize one of the components, one of the parts of the system that we had. Let's now look at the second one. Okay, that's a little bit more civil. There's not so many function calls. If we look at the function that 0x highlighted, we can see it's called process chunk. And if we go back to the architecture view, we can see that the part that is responsible for that function is here. It's where we send IPC data over IPC to our worker processes to actually do the rendering. So around that time in Node, there was an implementation of threads being developed. So I decided to figure out if I can actually use that in OpBox Web and improve the performance. So we went from this architecture when we have processes spawned for every worker to this architecture when everything is in one process, and instead of IPC, we use post message from workers to actually communicate the data between the node worker nodes library and OpBox. Okay, so this is the benchmark that I run on the dev environment. And as you can see, I've placed timers in places where we start sending the data and when we receive. And as you can see that the when we recorded the maximum time, the IPC was somewhere around 30 milliseconds. And we got really big improvement, really big jump in performance when we use post message and worker threads. So I was really happy. I was really excited to do that release and try that thing in production. But what actually happened was this. We barely moved the response time. It was a couple, like 1 or 2 milliseconds, but we didn't know what the hell was going on. So as you do, you should fire up a profiler and see actually what's going on, why we didn't get the improvement that we wanted. Okay, what's going on here? Why the flame graph is empty? Well, this is the function that was that's on top of the stack. It's libsystem pthread. That makes sense because we are now using threads. But what's going on here? Did the Node developers forget about profiling when they were introducing worker threads? So I submitted an issue on GitHub, and around that time was when my 2 weeks at OpBox ended. So I had to say goodbye to the OpBox guys, but I was really not happy with what happened with the optimization. I moved on after a week or so, so I started working on in my team on some regular stuff. And one day I got an email from GitHub that my issue went from unassigned to a confirmed bug. All right, so 4 months later, it got fixed in 11.10.0, and my plan is to run this analysis again, see what's going on, and try to optimize it even more. So to sum up the big wins that we got from my time working at OpBox, I was able to improve the rendering time by around 11%. Along the way, we managed to create tools to monitor the performance of OpBox, and we contributed to the evolution of node.js. So if you have performance issues, remember to run your profiling in production, find the biggest bottleneck that you can, optimize, and repeat. My name is Krzysztof Slonka, and thank you for listening.